Today's topic that we're going to go over is decompose and composing fractions greater than 1. Who can read the objective? Who can read the objective? Zoe?
Students will be able to decompose and compose fractions greater than 1 to express them in various forms.
Okay, so the purpose of this lesson today is to choose a method on how to convert improper fractions into mixed numbers. So you have two different strategies. You're going to either rename fractions using decomposition, which is to decompose, or you're going to convert a fraction to a mixed number using multiplication. Then, with both, we're going to show how to do that on a number line. So we did a little bit of that in 4.2 and 22 and 4.23, but now we're going to choose which one we want to do, okay? So let's get started. So we're going to decompose and compose fractions. So let's start with the first chart. So our improper fraction is 8/3. And how do we know 8/3 is an improper fraction? How do we know? Josh?
The numerator is greater than the denominator.
Yeah, so the numerator is greater than the denominator. So we're going to use decomposition. So we're going to make a number bond. So anytime you want to decompose a fraction, you're going to use a what?
Number bond.
A number bond. So the way we use a number bond, we have to use mental math. So the first thing we need to do is 8, and we need to look at 8 and 3. So we have to determine how many groups of how many groups of 3 we can get out of 8. We can get 2, but we have to create a fraction that will equal to 2. So that's 6/3. So if you would divide to see how many groups of 3 that you got out of 6, you get 2 wholes. And then whatever's left over becomes the additional fraction or the mixed number. So we have 2 left over. So to be sure, 8/3 equals 6/3 plus 2/3. So 6/3 plus 2/3 is going to equal 2. So you make this improper fraction to a whole number. So how many groups of 3 can you get out of 6?
2.
So that 2 goes here, and then you add the 2/3. So 2 plus 2/3 equals 2 and 2/3. So then we're going to create our number line. So what determines how many equal parts in between each whole number? What determines how many equal parts in between each whole number? Cosima?
The denominator.
The denominator. So the denominator is 3. So that means we're going to have 3 equal parts between 2 whole numbers. So if we count 6/3, it should be at the whole number what? 2. So 1, 2, 3, 4, 5, 6. So we have our 6/3, and then we also need to add our what?
2.
Our 2/3. So we have 1, 2. So 8/3 equals 2 and 2/3. But we decomposed it by using a number bond. Okay. So let's look at the next example. All right. So the next example is something like we did yesterday. We're going to convert a fraction to a mixed number using multiplication. So that means we're going to compose the fraction, okay? So we still have 8/3, so it looks a little bit different. So the first thing we're going to do is see how many groups of 3 we can get out of 8. We can get at least what? 2. So that's your whole number. So you will multiply that by 3/3. That would equal 1, okay? So then that equals 2 times 3/3 equals what? 6/3. So, and then we also add the 2/3 that's left over. So that's 6/3. It's just to take it into a whole number. We see how many groups of 3 we can get out of 6, which is 2, and then we add the 2/3. So then 2 plus 2/3 equals 2 and 2/3. Good. Now, how does this look on a number line? So, still, we know that it takes 3 equal parts to make one whole, right? So, this is different. So, now we would say 3 times 1/3 equals 1, because 3 times 1/3 equals 3/3, and 3/3 equals 1. So, we say 3 times 1/3 equals 1, then 3 times 1/3 plus that equals 2, and then we add on our what? 2/3. Okay? So you have a copy of this on your desk or your process chart. So when you work together as your groups, you can refer to the process chart so you don't have to look up to the board. Okay? Alright, so now let's practice again. And let me convert this. So you can get the process chart and you can put it in front of you, and I'm going to put my process chart and put them in the front of the board, okay? So the first thing we're going to do is rename using decomposition, or we're going to compose 7/3. So the first thing I want to do is I always like to rename or rewrite my improper fraction. And since I'm decomposing, I have to create a what? Number bond. Good. So I'm going to create my number bond. So with my number bond, the first thing I have to mentally say is how many groups of 3 I can get out of 7. And I know I can get at least 2. So what fraction, improper fraction, would I have that would equal to 2? That would equal to 2, so that I can show the remaining fraction. Luke.
6/3.
6/3. And then the remainder would be my numerator, and my denominator stays what?
The same.
So what would be remaining? Kendall?
1/3.
1/3. All right. So now I can make my sentence. So I can say 6/3 plus 1/3 equals. So now we have to divide. How many groups of 3 I can get out of 6? 2. That becomes the whole number 2. And then I add my what? 1/3. And then 2 plus 1/3 equals 2 1/3. Good. So now I need to show this in a what?
Number
line. So how many equal parts between each whole number?
3.
So it will be 3. So I would say 1, 2, 3, 1, 1, 2, 3, 2, then 1, 2, 3, and 3. So I have to show it this way. So just like on my process chart, I'm going to show 6/3. And then 6/3. And then I'm going to add 1/3. Does anyone need any clarification with this?
No.
Yes.
Well, I don't have clarification, but I had a question. So, do you always have to connect so the 6/3 to the whole number?
Yes, because how many groups of 3 can you get out of 6? 2. Yes. So you just divide it. So 6/3 also equals 2. Okay? All right, so now we're going to convert using multiplication. So I'm going to rewrite 7/3. And 7/3 is going to equal, the first thing I need to do is think, how many groups of 3 can I get out of 7? 2. I can get 2. So I would say 2 times 3/3. And then how much is left over?
1/3.
1/3. So 2 times 3/3 equals 6/3. And 6/3 equals 2. Because I can get 2 groups of 3 out of what? 6. Yes, ma'am.
So basically we're just taking the numbers that's up there and putting them
No. Yeah, so we're taking the same strategy. This one is using a number bond, and this one is using multiplication. So this is decomposing the fraction using a number bond. This is composing the fraction, so we're kind of skipping this step. Okay? Yes, sir.
So can't you just do like a quick check, like if you do 2 times 3 plus 1, that would equal 7, and that should be a quick check as well?
Yeah, there can be a check as well, I agree. But let's finish. So it's 2 plus the what? 1/3, which equals 2 1/3. And now we have to make our number line. So how many equal parts in between each whole number? 3. So 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, and 3. All right, so the difference is we're going to show width equals 1. So we're going to go 3 times 1/3, 3 times 1/3, and then we add what? 1/3. Excellent. Anyone need clarification? All right, so let's move to another example. All right, so we have 13/5. So this time you guys are going to help me out. So the first thing we're going to do is rename using, we're going to decomposition. So what is the first thing we need to do? What's the first thing we need to do? Miles?
Well, we need to turn 13/5 into a number line.
We have to create
a number bond.
a number bond. So we're going to create a number bond. So I like to rename it by going 13/5, and then we're going to create a number bond. So when we create a number bond, what do we do? What do we do when we create a number bond, Gabe?
So you need to see how many groups of 5 you can get out of 13, which is 2.
Which is 2. But will I write down the number 2?
No.
No. So what will I do?
You have to write 10/5
So why would I write 10/5?
because that's how many groups of 5 you could get out of 2.
Yeah, so you create a fraction that what? Equals a whole number, okay? So that would be 10/5. How many groups of 5 can you get out of 10? 2. So how many are left over? Yes, 3/5. All right, so what do I do next? What do I do next? I am decomposing a fraction. Yes.
You will add. Wait, no, sorry. You will add 10/5 plus 3/5.
Good. You'll add 10/5 plus 3/5. Then what do I do next? What do I do next? All right, close one.
You make 10/5 into a whole number.
And how do I make 10/5 into a whole number? Zoe,
You see how many groups of 5 you can get out of 10?
how many?
2.
2. So you have 2. And then what do you do next? So I have the 2. Then I what?
You add 3/5.
Then I add the 3/5. Excellent. So then what do I do next?
Can you
Yes.
put together?
So when we put together, we are we'll be adding, right? So what are we adding?
2 and
So 2 plus 3/5 is 2 and 3/5. So now what do we love to do? What are we going to do next? What we're going to do?
number line.
All right, so how many equal parts are between each whole number? 5. Why is it 5? Our lyric?
Because the denominator.
Because the denominator is 5. So what will be between which whole numbers? Which whole numbers? Yes. No, not 5. Between which whole numbers would our fractional number line be in? Yes. Postman, I'm sorry.
Between 0 and 3.
Between 0 and 3. Good. So let's count. So that's 0. So 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, and 3. All right. So I'm going to have my arc from here to 2. What fraction will represent that? What fraction will represent that, Joshua? 10/5. Because you can get 2 groups of 5 out of 10. And then I need to add on my what? 3/5. So 1, 2, 3. Excellent. So now I need to convert using what? Multiplication, which is, am I decomposing or composing the fraction? I'm composing the fraction. So the first thing I need to do, I always like to rename my fraction by write down 13/5. So now what do I do? What do I do? Kennedy.
You see how many groups of 5 you could get out of 13, which would be 2 times 5. Yeah, times 5/5.
All right, so it'll be 2 times 5/5. All right, so what do I do next? What do I do next? Lamaya?
You
help her out. Lulu?
Next you add 3/5.
Add the 3/5. Why do we add the 3/5? Lulu, why do we add the 3/5?
You add the 3/5 because since the answer is 2 and 3/5 and 2 times 5/5 equals still 2 and you add a 3/5 that would still equal.
Yeah, who can give us more clarification about Miles?
Because two groups of 5/5 is 10/5, and what's left over in those 13/5.
Right, so 3/5 is left over. Okay, so now what do we do? All right, Gabe.
You actually forgot to make the number bond
Well, we're using multiplication, so we're composing the fraction.
Well, on this I see a number bond.
Well, right here to show that 2/5 equals what?
10.
This equals 10/5. So what do we do next? Yes.
We do 2 plus 3/5.
All right, because you can get two groups of 5 out of 10, and then you add the 3/5. And then we have 2 plus 3/5, and 2 plus 3/5 equals
2 and 3/5.
Now what do we need to do?
Number
We make a number line. So how many equal parts between whole number? Everyone? 5. Good. In between, like Kosima said, between 0 and 3. So count with me. 1, 2, 3, 4, 5. 1.
1, 2, 3, 4, 5, 2. 1, 2, 3, 4, 5, 3.
All right. So what fraction would represent, or multiplication sentence would represent how to get to 1? Josh.
It would be 5 times 1/5.
Good. 5 times 1/5. And 5 times 1/5 equals 1. So then we do 5 times 1/5. It's another 1, and then we add what?
3/5.
3/5. 1, 2, 3/5. All right. So now it's time for you to do it as a team. So this is how you're going to earn Class Dojo points. So you're going to have your own fraction, and then you're going to have the bonus challenge, or the challenge question. The challenge question we'll do at the end of the lesson. So each team member is responsible to come up in front of the classroom to present whether you're going to compose the fraction or decompose the fraction. So you can choose which one you're going to do, okay? And then you're going to present, but you're going to speak in math what? Math and language. So when I call your team, come up. The team leader is going to come up, and then you guys are going to get started when I say go, because you're going to have 3 minutes, okay? So we're going to start with dangerous debaters. Come on down. Come on, dangerous debaters. Only one. All right, the team leader. Dominant debaters, raise your hand. All right. Thunderbolt. Destin. Classmates. Mighty. All right, so when I say go, yes. Yes. Please incorporate the number line. Now you can choose. Now if you have 3 minutes, you have time to do both, which is to compose and to decompose the fraction. You may, but when you come up to present, you're going to choose one and make sure you have a number line. Are there any other questions before we begin? Yes. Yes. Any other questions before we begin? All right. So on your mark, you have 3 minutes. Get set. And make sure you're speaking in math what? Language. Go. No, you need to first.
I mean, do we pick one version of how to do it? Do we pick one way?
So then we will create a number bond. Because so here, you have to create a number bond. So far I can need to because it's because 8 times 4 is 32.
10 squared. Okay, so
And then it will equal, to,
yeah.
so equal to,
Wait, no, first we have to do 30 times plus 5.
yeah.
30 times plus 5. So how many units do we partition a number? 6. I don't remember. Oh yeah, 6. First you have to go to 30 times that was time for perfection. Let's just partition it to I'm writing the number.
This will have to be toothpaste. That's very tiny. So basically, it's like one big one. Yes, we can. Now we do. Can I do it because I told fast? You okay on that? Yeah, so, right. So, basically, what it was supposed to make it to 3, right? So it's just 1, 2, 3.
All right, 30 seconds. You can do the challenge later.
So it's 2 times. Yep, 2 times 5/5. Now put that in red line. Plus 2. 2
Okay, so we can present that one time on that, okay? All right, let's go.
Okay, we're done. We can do
All right, so 5. Oh, I'm sorry, I got 9 seconds.
9, 8.
All right, 5,
You can get 9.
4, 3, 2, and 1. So, even if you weren't able to finish both, you should have a representation at least with decomposing or composing a fraction. So, if you are a team leader, you're not just going to write the problem up. As you are writing, you're going to do what? Explain what you're doing. So, I randomly picked the groups to go up. So the first group to present, and that's the team leader, will be the dominant debaters. You don't have to clap.
Oh, okay.
All right, I like how the classmates are sitting. Good job.
So should I bring
Mighty. Absolutely. All right.
So first, of course, we're going to read these.
So make sure you speak loud enough for everyone to hear.
So this will be 12. Oh, am I writing too small? Yes.
Yes.
How do you just have it?
Just hit the eraser.
It's right there.
Yeah, make sure you write large enough for everyone to see, okay?
So,
Get the pen, get the pen. There you go.
Okay, so first do 12 fifths, and then we're going to, of course, do our number bond, and that's 10 fifths and 2 fifths, which is the remainder. So now we're going to make that 10 fifths plus 2 fifths. Yeah. Let's try it. And then it's going to be 5. That equals 2 wholes. So that's going to be 2. Then add 2 fifths, and that equals 2 and 2 fifths. So now,
Good job. Okay, you may do your number line.
so now I have to do the number line. That. So 0, 1, 2, 3, 4. 1, 2, 3, 4. 2, 1, 2, 3, 4. 3. So now I just need to do 10 fifths is 2 fifths, so 10 fifths, and then 2 fifths, which is the remainder. And then
All right, raise your hand if you agree. All right, give him a clap. Good. All right, the next. Drum roll, please. Make sure you speak loud enough for everyone to hear. All right.
So first we're going to have to rename the fraction 26, and I'm going to use the convert using multiplication method. So 26, I know that there are 3 groups of I know that there are 3 groups of 6 in 20. So that's 3 times 6, 6. And then we add the remaining 6, which is 2, 6. So after you add that, that's gonna equal 3 plus 2, 6, which is going to equal 3 and that is going to equal 3 and 2, 6. And we know that 3 and 2 6 is equal to 3 and 1/3. So for my my number line, I know that we have to go from whole number 0 to whole number 4. So then this is 2, 3, and this is 1. And then we partition it into 6. So then we draw an arrow to here, and we draw another arrow to this to tick mark, and then we draw an arrow to 3, and then we do it to 2, 6. So this is add 2, 6. And for these, this is 6 times 1, 6. This is 6 times 1, 6. This is also 6 times 1, 6, because 6 times 1, 6 equals.
All right, raise your hand if you agree. All right, give him a clap. All right, so we're going to pause right now, and we're going to start with our problem set. So momentarily, I'm going to stop, and I'm going to call the next group to come up to work on their particular problem. If you have any downtime after your problem set, you're going to do the challenge question as well. Yes, sir.
I sort of disagree with Darsh's response because in the strategy it didn't really tell you to make it equivalent to a different fraction.
Meaning, because he simplified the fraction. We haven't gone over that yet. So that is accurate. He just went a little bit beyond, and we'll be doing equivalent fractions soon. Yes. Oh, the number bond? Yes. All right, can you create the number bond for 3 times 6, please? Thank you. All right, so extra, yeah. All right, good job. Good observation, everyone. So what you're going to do right now, you should have your process chart and your problem set. You're going to work together as a team. Now, if you're part of my team, you can take your papers and meet me at the back table. Make sure that you use your buzzing sound. And if you need clarification, ask your teammate.
Okay. I don't think we work together on this one. You also did. Okay.
Yes, what are going to do? Everyone have their pencil? All right, so we're going to start. Someone read the directions, please. Read the directions.
Convert each fraction to a mixed number. Show your work as an example. Model with a number line.
Okay, so it's asking us to decompose the fractions. So everyone, you have your process chart? So we're going to look at where we decompose. So that's the first one, okay? All right, so you see they did the first one with 11/3. So they broke it down to see how many groups of 3. You get out 11, you can get 3. So 9/3 equals 3, and then 2/3 is left over. So then 9/3 plus 2/3 equals 3. So what they did was they took the 9/3 and divided it, and then added the 2/3, and then it's 3 and 2/3. Okay. So now let's look at the another one for 12/5. So let's rename. So rewrite your fraction. All right. So how many groups? So how many groups of 5 can you get out of 12? So 3 times 5 is 15. So 2. And what's 2 times 5? So what fraction would we have that would equal to 2? So if 2 times 5 is 10, 10 will become our what? Our numerator. And our denominator stays what?
The same.
All right. So these two fractions right here have to equal 12. So we have 10/5. What fraction would we add that when we add these together we would get 12/5? 2/5. Good. So 2/5. So that's our new addition sentence. So our new addition sentence would be 10/5 plus what? 2/5. Let's put an equal sign. So what do we do next? Yeah.
And it will be 2 plus.
Let's talk about, so we know it would be 2. Why will it be 2? Yes. Why will it be 2, Mariah?
Because it will you divide 10 and 10.
No, so when you divide, yes. How many groups of 5 can go into 10? How many groups of 5? It'll be 2. So put your arrow in 2, and then you add your what? 2/5. And then 2 plus 2/5 equals 2 and 2/5. All right, so let's look at the denominator. What is the denominator in this equation? 5. So how many equal parts will be between each whole number? 5. So it'll be between 0 and 3. Good. So make your number line. Start with the first one. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2. 1, 2, 3, 4, 5, and 3. So let's look at our number line, right? Which fraction will we have to show first? We will have to show 10/5, right? So 10/5 will stop at the 2, right? So we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/5. So how many fifths are left over? Not 1/5, 2/5. 1 and 2. So make sure you label your whole number line, Sanaya. Make sure you label it with your whole numbers. All right, so let's move on to the next one. So the next fraction is what? 13 halves. 13 halves. So let's make our number line. So how many groups of 2 can we get out of 13? Good, 6. So what we would do is what's 6 times 2? 12. So that would be 12 over what? 2. Then how many are left over? Huh? Because the denominator is 2. It'll be 1/2. Good. So what do we do next?
So we're doing a multiplication.
No, we're still decomposing.
Oh, so now we do not 6, 12
Halves.
12 halves,
12 halves
1/2,
plus 1/2.
and that will equal
So let Lamaya go next. So 12 halves plus 1/2 will equal what?
2.
Well, how many groups of 2 can you get out of 12? No, you can get more than 2. Help out, Cache. How many groups of 2 can we get out of 12? 6. So 6. And then we add the what? 1/2. So then if we have 6 plus 1/2, that equals what? 6 and 1/2. All right, so how many? Yes.
So we just
1/2 is left over. The 2 is the denominator. All right, so let's make our number line. Our number line is going to be between 0 and 7. 0 and 7. How many equal parts between each whole number? 2, because the denominator is 2. So we say 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 2, 6, and 1, 2, and 7. So we need to stop at 12 halves, and we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you should stop at what? 6. And then we have, well, how many left over? 2. No? No, 1/2. So label yours accurately, please. So you would count out 12 halves. So you would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12.
Miss Cakes, with the 1/2 will end at right here, right?
Yes.
you're not counting.
Then you need to take your 12 now, 12 halves, and then split it, and then it's 12. What?
So now you need to count. You need to count 12 halves. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should stop at 6. So that means you have to have 2 equal parts. You see how mine look? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Because it's 2 equal parts into each whole number. Okay. So rewrite your number line. So it's 1, 2, 1. Then do it again. 1, 2, 2. 2, 2. Then 1, 2, 3 until you get to 7. Alright, so while we're waiting on Lamaya, someone work on 15/4. 15/4. So you guys can work on it by yourselves. And then we're going to see what you come up with so far. And then see where you get stuck. Okay, so now if you count to 12, it should stop at 6. So try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So make your line, and that will be 12 halves, and then you add your half.